Right now on your screen, you can see a gem hunter pulling a green stone straight out of his backyard. A completely unexpected place, full of dirt and ordinary rocks, yet hiding a beautiful green gem. And if that stone happens to be an emerald, it could easily be worth thousands of dollars. At first glance, it looked dull, just another pebble buried in the soil. But after brushing off some dirt, it revealed a glassy shine that immediately stood out. And here's the fascinating part. That stone hasn't even been cut or polished yet, which means that once it's faceted, it could look even more beautiful and far more valuable. So let me ask you, if this happened to you, would you know what kind of stone you were holding? Could it just be green quartz with no real value? Maybe a piece of jade like the ones carved into sculptures and jewelry across Asia? Or, against all odds, a true emerald, one of the most valuable gems in the world? No matter what your answer is, the truth is that this situation could actually happen to you. Most people never imagine that precious stones could show up in places as ordinary as a backyard. That's why so many just step over them or throw them away, not realizing they might be holding a gem worth serious money. And here's the key. If you live in an area with metamorphic rock formations or even soils derived from pegmatites, there's a real chance that valuable green minerals are present. Sounds too technical? Don't worry. By the end of this video, it will all make sense. You're about to learn how to recognize the rare green gemstones that could appear near your home. We'll cover their main characteristics, the types of rocks where they usually form, how much they're worth on the market, and most importantly, how to tell the difference between an ordinary stone and a crystal that could sell for hundreds or even thousands of dollars. And we're not stopping there. For each gemstone, I'll show you the real market price ranges and explain exactly what makes one stone more valuable than another. You'll see why two crystals that look nearly identical can end up with completely different values, and which details professional buyers and gemologists pay attention to before making an offer. So get ready, because from now on, every time you come across a green stone in your backyard, on a trail, or even during a casual walk, you'll never look at it the same way again. Among all the green stones someone might come across at home or during a walk, the easiest one to find is without a doubt green quartz. Quartz is the second most abundant mineral in Earth's crust, and small variations in its composition or in the conditions of formation can give it a greenish color. These crystals may form inside pegmatites, coarse-grained igneous rocks that cool very slowly, allowing large crystals to grow, or in hydrothermal veins, which are fractures filled with hot, silica-rich solutions. In these environments, quartz grows in massive clusters or elongated prisms, and when it contains inclusions of minerals like chlorite or actinolite, it develops green tones. For the untrained eye, green quartz can easily be mistaken for ordinary glass or even for old bottle fragments that end up rolling around in soils or riverbeds. But there's a simple way to tell them apart. Quartz is much harder. It ranks 7 on the Mohs hardness scale, which means it scratches glass easily, while glass cannot scratch quartz. Another clue is the luster. When held to the light, quartz tends to have a stronger vitreous shine and often shows natural crystal faces, even if irregular, while glass usually breaks with curved fractures and has no crystalline structure. These subtle differences are critical to avoid confusing a valuable crystal with a piece of bottle glass. One of the best-known varieties of green quartz is prasiolite, sometimes called green amethyst or vermarine. The name itself is misleading because in practice, natural prasiolite is extremely rare. Most of the stones sold under that name are the result of heat treatment or irradiation, usually applied to amethysts or yellowish quartzes. When heated under specific conditions, the iron atoms in the crystal structure shift states, turning the purple hue into green. That's why so many experts in the gem trade emphasize the importance of knowing the stone's origin. While natural prasiolite has only been confirmed in a handful of places worldwide, such as Lower Silesia in Poland, Bahia in Brazil, Thunder Bay in Canada, and a few mines in Namibia. The overwhelming majority of prasiolite on the market comes from treated quartz, mostly Brazilian material. This distinction has a direct impact on price. Natural prasiolite is rare and can fetch higher values, especially if it has a vivid color and good transparency. Treated stones, although beautiful and widely used in jewelry, are more affordable. In general, a prasiolite gemstone cut from treated quartz sells for a few dozen dollars per carat, while natural specimens can reach several $100s per carat depending on size and quality. So if you come across green quartz in your backyard, it's unlikely to be natural prasiolite, but it can still be material prized by collectors and lapidaries. Alongside quartz, another green stone worth noting is Veracite. Unlike quartz, Veracite is a hydrated aluminum phosphate that ranges from light green to bluish green, often with veins or mosaic-like patterns running through it. This appearance, with its networks of natural designs, frequently causes Veracite to be confused with turquoise. The difference lies in both the chemistry and the tone. Veracite usually has a purer green color with less blue saturation than turquoise. In the United States, Veracite has special significance because it occurs in Utah, where it has even been called Utahite, and also in parts of Nevada. These localities are now world references for this mineral, and many polished cabochons sold at mineral shows and in jewelry stores come directly from these deposits. Germany has also produced Veracite on a smaller scale, but in terms of reputation and availability, the Western US is where it truly stands out. As for market value, Veracite is considered a semi-precious gemstone, but that doesn't mean it can't reach interesting prices. Lower quality material used in crafts or sold at local fairs may go for less than $2 per carat, but high-quality cabochons with uniform color and striking internal patterns can easily sell for $20, $40, or even $60 per carat. Very fine specimens with emerald-like green tones and good translucency are even more valuable, especially among collectors of rare minerals. These stones, green quartz in its varieties, and Veracite are perfect examples of how relatively affordable gems can show up in ordinary places, including backyards and hiking trails. The secret lies in learning to recognize the signs: a vitreous shine that remains even in the shade, the flat fracture planes typical of quartz, or the soft, distinctive green of Veracite. Details that most people overlook, but that can reveal stones which are not only beautiful, but also hold real market value. When it comes to green gemstones that fascinate collectors and buyers, jade carries the greatest cultural and historical significance. For many, jade is about more than just beauty. In numerous cultures, it also represents power, spirituality, and status. That's one of the reasons why jade is considered among the most valuable green gemstones in the world. But for anyone trying to identify precious stones in ordinary places like a backyard, it's essential to understand that jade is not a single mineral. In reality, there are two distinct varieties that share this name: Nephrite and Jadeite. It's much more likely that you'll come across Nephrite since it is the more common of the two. Nephrite forms in metamorphic environments, where ultramafic rocks rich in magnesium undergo intense alteration. The result is compact green masses with a dense fibrous texture and a greasy or waxy surface. This texture gives nephrite its unique, almost soapy feel when handled, something that often surprises those holding a piece for the first time. Nephrite is typically associated with serpentinites, amphibolites, schists, and gneisses, all reliable indicators of geological conditions favorable to jade formation. Jadeite, on the other hand, is much rarer and far more valuable. Chemically, it belongs to the pyroxene group and contains sodium and aluminum. It forms in subduction zones, where one tectonic plate is forced beneath another, creating the extreme pressure and temperature conditions needed for jadeite to crystallize. Such environments are rare worldwide, which explains the exceptionally high prices jadeite can command. Unlike nephrite, which usually shows a uniform, opaque green, jadeite can display vivid, translucent greens. At its best, it reaches the world-famous imperial jade color, the highest standard of quality for jade. The value of these two varieties differs enormously. Medium-quality nephrite, often used for carvings, beads, or small jewelry, may cost just a few dollars per carat. Higher-quality translucent nephrite with an even color can reach several $100s per carat. Jadeite, however, is in a completely different category. Even small cabochons of vivid, translucent jadeite can sell for hundreds to thousands of dollars per carat, while fine imperial jadeite routinely achieves tens of thousands of dollars per carat at international auctions. That difference highlights the importance of knowing exactly which variety you're dealing with. In the United States, nephrite is found in several northwestern states, including Wyoming, California, and Alaska, usually in deposits associated with serpentinites and schists. While much of this material is medium grade, it remains highly valued for carvings and lapidary work. Jadeite, however, does not occur in significant quantities in the U.S. The world's most famous deposits are in Myanmar, the historical source of the finest imperial jade, with smaller occurrences in Guatemala and Japan. Field identification also helps. Nephrite tends to be more resistant to breaking and shows a fibrous, compact texture when fractured. Jadeite, by contrast, is more granular in structure and often more translucent, especially in thin slices. Professional gemologists confirm jade varieties through density and refractive index testing, but even in the field, careful observation of color, translucency, and texture gives strong clues. Associated minerals also provide hints. Actinolite, Peridot, magnetite, and chlorite often appear in nephrite-rich environments, while serpentinites in subduction zones point toward jadeite. On the market, jade continues to be one of the most sought-after stones worldwide. In East Asia, especially in China, jade is considered a symbol of purity and longevity, which sustains demand for the highest quality specimens. This cultural importance pushes the price of imperial jadeite to levels that can equal or even surpass those of fine diamonds. So for anyone who stumbles upon a green stone in a region with serpentinites, caution is key. What looks like just an opaque pebble may in fact be nephrite of considerable value. And while the odds of finding jadeite in common U.S. environments are slim, nephrite has indeed been discovered by amateur gem hunters and collectors in metamorphic zones. Speaking of the most valuable green gemstones, emeralds are at the very top of the list. Unlike other minerals that occasionally exhibit green hues, emerald belongs to a very specific family, beryl. It is composed of beryllium, aluminium, silicon, and oxygen. What transforms a transparent beryl crystal into an emerald is the presence of trace amounts of chromium or vanadium. These elements give emerald its vivid green color, ranging from lighter tones to the deep, saturated hues considered the finest. Beryl itself occurs in many colors. Blue beryl is called aquamarine, pink is morganite, yellow is helidor. But when chromium or vanadium atoms enter the crystal structure, the result is emerald, one of the world's most prized gemstones. Emerald formation is rare. It requires a unique geological meeting of two rock types that usually don't occur together. A source of beryllium, typically granite pegmatites, and a source of chromium or vanadium, usually ultramafic rocks or chromite-bearing schists. Where these two environments intersect, often along fractures and metamorphic contacts, emerald crystals can grow. That rarity explains why emerald deposits are concentrated in so few places worldwide. Globally, the best-known sources are Colombia, Zambia, and Brazil. Colombia in particular is famous for emeralds of unmatched clarity and color saturation. Considered the gold standard of the trade, but few people know that the United States also hosts emerald and other green beryl occurrences. In North Carolina, historic emerald deposits exist in the region of hiddenite, which also gave its name to the rare green variety of spodumene found there. Emeralds in this area occur in schists and pegmatites within metamorphic zones. Some specimens from North Carolina have rivaled Colombian stones in quality, proving that American geology can also produce remarkable gems. Today, parts of the state still allow visitors to explore and collect colored beryls from secondary deposits. Another example is Montana, better known for sapphires but also home to occurrences of green beryl and granite pegmatites. While these deposits are not large-scale producers, they demonstrate the geological diversity of beryl in the U.S. Smaller finds have also been documented in Connecticut and Maine, again linked to pegmatite formations. Identifying emeralds in the field can be challenging. In rough form, they don't always show the brilliant green we see in jewelry. Often, emeralds appear as medium green prismatic crystals, partially embedded in quartz or mica. A hardness test can help. Beryl ranks 7.5 to 8 on the Mohs scale, harder than quartz. Density also gives clues. Emerald tends to feel heavier in the hand compared to quartz or glass of the same size. Once cut and polished, emeralds display their famous brilliance. But it's important to remember that nearly all emeralds contain internal inclusions, often poetically called gardens. These fractures, bubbles, and tiny mineral veins are natural features. While they reduce durability, they also confirm authenticity. And the market still values emeralds highly, even with visible inclusions. An emerald's value depends on three main factors: color, clarity, and size. Stones with vivid, saturated green, without leaning too much toward yellow or blue, are the most valuable. Pale or overly dark emeralds are less prized, as are stones heavily fractured. Commercial quality emeralds may sell for a few dozen dollars per carat, but high-grade emeralds, especially fine Colombian gems, can easily reach thousands of dollars per carat at international auctions. Exceptional specimens have sold for tens of thousands of dollars per carat. Other green beryls that don't meet emerald quality standards also hold value. Light green beryls, sometimes mistaken for slightly greenish aquamarines, are less valuable but still desirable for cutting and collecting. They can be found in U.S. pegmatites and are accessible to hobbyist prospectors. While they don't reach emerald-level prices, they're still considered noble gemstones and maintain a steady demand in the market. Among green gemstones, emeralds and jades usually take the spotlight, but there are other equally fascinating varieties that appear under specific geological conditions. They don't always reach the same prestige or value, but they hold great importance for both collectors and the gemstone market. Three in particular deserve attention: Peridot, diopside, and hiddenite. Peridot is the gem variety of the mineral olivine, which belongs to the nesosilicate group. Its characteristic green color comes from iron in its crystal structure, ranging from yellowish tones to deep green with an oily luster. Unlike many gemstones that form in complex metamorphic environments, Peridot originates deep in the Earth's mantle, crystallizing under high temperature and pressure before being carried to the surface by volcanic activity. When basaltic eruptions bring this material up, olivine crystals often cluster into nodules, known as xenoliths, embedded in basalt. In the United States, some of the most famous deposits are in Arizona, especially on the San Carlos Apache Reservation, considered one of the world's leading sources of gem-quality peridot. There, crystals occur in olivine-rich basalts and, once cut, reveal intense green tones that vary depending on iron content. Hawaii is also famous for its green sand beaches, formed by eroded olivine fragments from ancient lava flows. While those grains have no individual gem value, they are an impressive reminder of how abundant olivine can be in volcanic environments. Peridot prices vary widely. Small crystals, common in Arizona, may cost just a few dollars per carat, but larger stones with saturated color can fetch much higher prices, reaching hundreds of dollars per carat. Although they rarely match emeralds in value, fine specimens are highly sought after, especially since natural peridot typically undergoes no treatments. That means its beauty is genuine, without heating or irradiation to enhance color, something collectors appreciate. Another green gemstone of interest is diopside, a calcium-magnesium pyroxene that occurs in metamorphic and igneous environments. The most famous variety is chrome diopside, whose vivid green comes from chromium in its structure. It usually forms prismatic crystals in calcium and magnesium-rich metamorphic rocks, such as marbles and skarns. But it can also appear in deposits related to ultramafic intrusions. While most people associate gem-quality diopside with Siberia, where translucent, brightly colored stones are faceted, it also occurs in parts of the United States. In the Appalachians, it has been reported in gneisses and schists, though not always of gem quality. In the field, diopside can be recognized by its dark green color, vitreous to greasy luster, and distinctive cleavage in two nearly perpendicular directions. That cleavage helps distinguish it from similar minerals like actinolite. On the international market, diopside is relatively affordable compared to emeralds, generally ranging from $10 to $100 per carat depending on transparency and color saturation. Higher quality stones, especially those cut into brilliant facets, display a rich green reminiscent of Savorite garnet, but at a lower price point. This makes chrome diopside an appealing option for green jewelry, with both aesthetic and economic value. The third gemstone in this group is hiddenite, a rare green variety of spodumene. Spodumene is a pyroxene mineral that can appear in several colors, including lilac, kunzite, and green, hiddenite. Hiddenite was discovered in the late 19th century in Hiddenite, North Carolina, the locality that gave the gem its name. Its green color results from chromium, just like emeralds. Geologically, hiddenite is associated with lithium-rich granite pegmatites, where spodumene crystallizes in large prismatic forms. The green color, however, is extremely rare since it requires chromium under very specific conditions. As a result, gem-quality hiddenite deposits are scarce, found mainly in North Carolina and a few isolated occurrences worldwide. On the market, hiddenite is considered a collector's stone. Small, pale-colored stones can be bought at modest prices, while well-formed, translucent, saturated specimens may reach hundreds of dollars per carat. Its rarity, combined with its direct connection to a classic American mineral locality, makes hiddenite highly desirable among serious collectors. Together, peridot, diopside, and hiddenite highlight the diversity of green minerals that form in different geological settings. From the basaltic volcanism of Arizona and Hawaii, to the calcium-rich metamorphic terrains of the Appalachians, to the lithium-bearing pegmatites of North Carolina, nature has multiple ways of producing green crystals. Though less famous than emeralds and jade, these gems carry beauty and value of their own. Knowing which rare green gemstones exist is only half the journey. The other half, just as important, is learning how to identify them in the field using simple tools and direct observation. Often the difference between someone who finds a gemstone and someone who walks past it is the ability to recognize subtle details: hardness, density, luster, and texture. The first essential test is hardness, based on the Mohs scale, which ranges from 1 talc to 10 a diamond. Quartz, for example, has a hardness of 7. That means it can scratch common glass but won't be scratched by it. If you pick up a green stone and want to check whether it's quartz, try scratching it with a steel blade or piece of glass. If the stone scratches glass easily but isn't scratched back, it's a strong clue that it might be quartz or something harder. Emerald, as a variety of beryl, has a hardness of 7.5 to 8. Jade is slightly softer, around 6 to 6.5, making it durable but still scratchable by quartz. These simple numbers help quickly rule out softer materials like calcite or gypsum. Another key factor is density. Different minerals of similar size can feel heavier or lighter in the hand. Collectors call this the heft test, and it's very practical in the field. Emerald has a density of about 2.7 to 2.8 G per cubic centimeter, while nephrite jade is denser, around 3.0. Glass, which often fools beginners, feels lighter and less compact. With practice, this perception can be decisive in distinguishing a valuable stone from a natural imitation. Luster also gives clues. Green quartz and emerald both have a vitreous luster, meaning they reflect light like polished glass. Nephrite jade, on the other hand, tends to look greasy or waxy, with a slightly duller surface even when polished. These details, visible to the naked eye, become even clearer with a 10x loupe, the most basic tool for any amateur gemologist. With a loupe, you can observe fractures, inclusions, and subtle textures that aid identification. Beyond testing, knowing where to look is crucial. Local geology often determines whether green gemstones are likely to be present. Ultramafic rocks such as serpentinite are strong candidates for hosting nephrite jade. These mantle-derived rocks usually occur in metamorphic belts. If you spot exposed serpentinite, pay attention to associated minerals like actinolite, epidote, and magnetite, classic indicators of nephrite. Granite pegmatites are another important target. These coarse-grained igneous bodies can host green beryls, including emerald, when chromium or vanadium is present. In the field, pegmatite appears as a light-colored rock with very large grains of quartz, feldspar, and mica. Cavities within pegmatites may hold large crystals. In states like North Carolina and Maine, pegmatites have yielded green beryls of gem interest. Riverbeds near serpentinites or pegmatites often act as natural concentrators. Erosion washes fragments into streams, where water carries them to accumulation points. These trap points include inside bends, zones behind boulders, or depressions in the riverbed. Because gemstones are denser than common quartz, they tend to settle in these spots. With a sieve or pan, you can separate heavy minerals from sand and spot small gems. Indicator minerals also help. Finding garnet, magnetite, or abundant mica in an area often signals the same conditions that favor emeralds or jade. Experienced prospectors sometimes track these accessory minerals rather than the main gem itself, following the trail until they reach the source deposit. With just a loop, a steel blade, a piece of glass, and a small portable scale, anyone can apply these basic tests and cut down on false positives. The key is combining geological knowledge of the terrain with detailed observation of the specimen. This dramatically reduces the risk of mistaking a common stone for a gem, or worse, discarding a real gemstone while thinking it's just an ordinary pebble. Now imagine that after watching this episode, you decide to check a patch of soil in your backyard, or maybe the gravel path you walk across every day without giving it a second thought. Among the ordinary stones, you notice one with a faint green tone. It feels heavier than it should, and when you tilt it under the light, you see a subtle, vitreous shine that doesn't disappear in the shade. Your first thought comes quickly. Is this just a piece of quartz? Could it be jade? Or did I just stumble upon a real emerald? It's in this exact moment that the doubt itself is more valuable than the stone. Many viewers of this channel have shared stories of finding unusual green crystals, but hesitating to test them, afraid of damaging them or lowering their value. Others sold them for just a few dollars, only to later discover they had peridots, veracites, or even beryls that could have been worth hundreds. And here lies the big lesson. Finding the stone is only half the journey. The real value is in knowing how to recognize what you found. Hardness, density, luster, crystal shape, even the minerals surrounding it. These are simple tests you can perform at home without a lab, using nothing more than a glass plate, a steel blade, a small scale, and a loop. This practical knowledge is what transforms a stone that most people would ignore into a true discovery. Now think about this. If quartzes, jades, emeralds, peridots, diopsides, and hiddenites can all be hiding inside ordinary rocks, how many other gemstones might be going unnoticed right under our feet? That dull green pebble in your yard, the one you'd normally kick aside, could actually be the key to finding minerals far rarer and more valuable than you ever imagined. That's why we created the guide Gemology Journey for Beginners, a practical manual with comparison images, basic field tests, and clear instructions for anyone starting out as a gem hunter. It's the tool that keeps a valuable stone from ending up in a drawer mistaken for glass, or worse, being thrown away. But if now isn't the right time for you to get the guide or become a member, that's no problem at all. You can still stay subscribed to the channel and follow every video for free. In fact, in the next episode, we'll go even further, revealing how to identify red gemstones hidden in the very same environments where these green ones appear. One more step in transforming the way you see the mineral world. So remember this, the next stone you almost ignore might be your greatest discovery. Thanks for liking and subscribing to our channel. Good luck, Gem Hunter!